This Instructable is to take advantage of a couple of cool new oscilloscope apps. One is an Apple app, which I haven't tested, called Synthopia, and an Android app called Aussie Prime, which I have here both on my tablet and my smartphone. Both of these apps will trigger on an audio input signal through the microphone, so you can analyze the sound. But I realize these apps can also be used in a novel way to collect data in the classic falling body experiment in a physics lab. To take advantage of the audio input capability of the app, I've created a couple of photo gates that are darkness activated. I'm using just a cat toy laser pointer as the beam, and a couple of simple phototransistor circuits that I will give more details about in a minute. And they're hooked up to this buzzer. Both of them are hooked to the same buzzer up here. So let me just give a demonstration. First thing you would do in a physics lab is measure the distance between the beams, and then drop your objects. As you can see, we picked up the ball passing through both photo gates, and by using the time measurement tool, and you can expand this to make it more accurate, and putting it at the beginning of each signal, then you can look down here in the corner and it will tell you that the elapsed time was 279 milliseconds. In a classroom setting, one of the neat features of this is that you can take a snapshot of it over here using a little camera, and then you can email it to classmates and let them do their own measurements, crowdsource the entire thing. This is the circuit diagram for the dark activated photo gate. You'll notice that I use a phototransistor here. Do not use a photoresistor or a photocell. They're just not fast enough. If you put a relay or something in there, that'll slow it down and make your results less accurate. If you have access to Radio Shack in your area, I've listed the parts there, but of course you can use any parts of your choice. This is a completed photogate circuit. You can see two wires coming out. One goes to the phototransistor, which fits into a hole in the wood. The other goes to the piezo buzzer. The other side of the gate has the laser pointer. The button is held on with a spring-loaded clothespin. As mentioned before, there's only one piezo buzzer necessary, as they can all be wired up to the same one. You can create as many of these photo gates as you want, but you can get away with just two by taking measurements and then just moving it to a different location. Well, that's it. I know that there are physics labs out there that use cameras, and you can dump that into some sophisticated software, which is great. That works great too. This is a little bit more hands-on, where kids have to learn to use an oscilloscope. And so if you think that's useful, give it a try.